this video, we're going to complete notes on identifying, sketching, and intro to angle properties. Our I can statement for this standard is I can identify and use properties of right, acute, obtuse, straight, vertical, complementary, and supplementary angles. So there's a lot of different properties that we will review in these notes. The first part wants us to organize the following 9 angles into 4 distinct groups. So we're going to quickly look through these 9 angles. So I notice in this first angle, it's 126 degrees about. The second angle is about 90 degrees. The third angle is about 49.5 degrees. I have an angle that's 128.9 degrees, 31.8, 180, another one that's 180, 158 degrees, and 90. So looking through these, the 4 distinct groups that I want to organize them in are the groups acute angles. So group 1 will be acute angles. Group 2 is going to be obtuse angles. Group 3 is going to be right angles. And group 4 is going to be straight angles. So acute angles, those are all the angles that are going to be smaller than 90 degrees. So when I go through and I look at all my angles, if I look at the first row, the last one in the first row, angle DCN, is less than 90 degrees. So that's going to be an acute angle. So angle DCN. Make sure when you're writing angles, you use the angle symbol in all capital letters. The vertex must be in the middle. The other acute angle is in the middle row, middle angle. And that is angle YTR. It's less than 90 degrees. So the other acute angle is angle YTR. The next group was obtuse angles. So obtuse angles, we're looking for angles that are bigger than a right angle, bigger than 90 degrees. So the very first angle, it's about 126 degrees, is angle BCD. That's bigger than 90 degrees. So this obtuse angle is angle BCD. That's an obtuse angle. The next obtuse angle is in the second row, 129 or 28.9 degrees. That's angle WMQ. So the next obtuse angle is angle WMQ. And the last obtuse angle is in the last row in the middle, angle JLR. It's bigger than 90, it's 158.5. So angle JLR. The next group we're looking for are right angles, which we've talked about before. Those are exactly 90 degrees. They'll be marked with a box, or they'll write the measurement of exactly 90 degrees. There was 2 of them. In the first row, the middle one, angle AEF, was 90 degrees. So angle AEF. And then in the last row, the very last angle was 90 degrees, right angle. So angle FGV. Or VGF, I guess it's written that way here. It's the same thing, as long as G, the vertex, is in the middle, we're good. The last group is straight angles. So those look like straight lines. They're 180 degrees. So I have 2 of those. I have the middle row, the last one, angle ZYX is exactly 180 degrees. So angle ZYX. And then in the last row, the first one, angle SAX is also 180 degrees. So angle SAX. So it says explain the way in which you group the angles. we grouped them by size. Okay, and on the next page we'll write definitions of all the different sizes of acute, obtuse, right, and straight angles. So if we go to the next page, we have some vocab that we need to write down. So the first vocab we want to do is an acute angle. So an acute angle is an angle that measures less than 90 degrees. So it needs to be less than 90, not exactly 90, less than 90. So they're always going to look acute. So there'll be some examples are like that, or it'll be just slightly less than 90. Okay. The next vocab we want to do is an obtuse angle. So an obtuse angle is an angle that measures more than 90 degrees, but it's also less than 180 degrees. So it's more than 90, but less than 180 degrees. So those will look bigger than 90 degrees, but they're less than a straight line. So even that could be a really big obtuse angle. Okay. The next vocab is a right angle. A right angle is an angle that measures exactly 90 degrees. It's exactly 90 degrees. They'll sometimes put the box there for you, but it should look exactly 90 degrees. The last vocab we want to do is a straight angle. So a straight angle is an angle that measures exactly 180 degrees. So it's exactly 180 degrees. It looks similar to a straight line. Okay, it'll have 3 points. The vertex is always in the middle, but this is always 180 degrees. So acute angles are less than 90. Obtuse angles are more than 90 but less than 180. A right angle is exactly 90 degrees, and a straight angle is exactly 180 degrees. Now, we're going to move on and apply some of these properties to find missing angle measurements. So if I look at this first one, this angle here is a question mark. So it looks like I have two angles connected to each other. So if I look here, angle BCM, this straight angle here, should equal 180 degrees. Okay? So angle BCM is a straight angle. And straight angles should equal 180 degrees. So if I have part of that straight angle, so this part DCM is 70 degrees, We need to know what the other part would be to make this whole thing equal 180 degrees, which is the straight angle. So I'm going to call the missing angle, I'm going to call it x instead of a question mark, because I want to set up and solve an equation in order to find the missing angle measurement. So when I combine these two angles, the missing angle x and 70, when I add them together, it should equal 180 degrees because BCM is a straight angle. So angle x plus the 70 degree angle should equal 180 degrees. So now we have to solve this one-step equation to figure out what is missing for that angle. So the inverse of adding 70 is subtracting it from both sides. So I end up with x being equal to 110 degrees. So that missing angle is 110. And a way to check is if I add these two numbers together, 110 plus 70, I should get 180 because it's a straight angle. The next one is very similar. I have angle MCB or BCM. Again, I have a straight angle. So angle MCB